Okay, so I want you to, for the first discussion, look at the following picture for 5 seconds that I'll display it. I want you to write down as many details as you can remember. And then afterwards, you're going to see the image again. So I'm going to show it for 5 seconds, and I want you to pause the video, write down things, and then once you replay, you'll see the image again. Ready? 1, 2, 3, 4, 5. Okay, pause the video now. Okay, now I can just get started. Okay, now I want you to write down as many details as you can about the picture while having access to it. So now just write down as many details as you can kind of see. Okay, that's probably pretty good. Okay, so this is a Salvador Dali painting. So it's surrealist imagery. So it's stuff you will never see really in real life. That's why I wanted to show it to you. That way you have the imagery to kind of draw from, and it'd be a little more interesting to you. Anyway, that's the idea. So who kind of remembered pretty well what was going on? Okay, did you look at sort of have you compared, or somebody compare for me the differences in what they remembered from the 5 seconds to what they actually saw? Like, were there mistakes?
My memory from just looking at it for the first 5 seconds, there were more broad details.
Mm-hmm.
Staring at it was more specific details.
Gotcha. Yeah, so you had this broad overview for a short amount of time. Since it wasn't seen to you, the imagery kind of fades, right? So you only remember those big, resounding, standout elements. Mm-hmm.
My mistake was that because I saw the sky as a background, I wrote down that they were like the animals were flying, but just had long legs.
Yeah, it is kind of, it looks like they're flying though, right? So it's sort of that little detail, like animals in sky, are they flying? Mm-hmm.
Somehow I managed to remember the cross in the bottom left-hand corner, but I didn't remember the horse.
The horse, yeah. Yeah. The things that stick out to you in that short amount of time, yeah, really leave that impression. So that's really your percept, right? That thing popped into your mind, whereas like the image of whatever, even though you saw it, might have faded. Mm-hmm.
I thought they were all horses at first.
That they were all horses?
Yeah, because the first one is just a horse, and you just assume that everything's a horse.
Yeah, all the weird stuff that it seems like it would be a horse. Mm-hmm. Mm-hmm.
I saw I guess it's the wood, or on their hooves are like golden looking.
Yeah.
I've never seen that before, so I was trying to figure it out during the last second, and then I guess time ran out. So then when I was remembering, I just wrote gold horseshoes, and the horseshoes aren't actually gold. It's what's underneath it.
Yeah, that's a nice detail. Because, yeah, that does look weird, doesn't it? It does kind of look like a wood grain horseshoe rather than the normal. So it causes you to kind of fixate on that element. Nice. Your perception of that. Mm-hmm.
I thought I saw an angel, but it's a woman holding her boobs.
Yeah, a little bit of nudity here. But we're all adults, remember? I just think that Dali has very beautiful images, so I wanted to show you. Mm-hmm.
I didn't realize that there were elephants carrying everything, and I just saw like the really long legs, like that were like really like fine lines. So I just wrote everything is melting.
Everything is melting. Ooh.
I thought that it was just like everything just had like lines coming.
Yeah, it sort of has that.
It's the elephants with like really long legs.
Mm-hmm. It's that strange impression of that.
It's
Yeah.
Salvador Dali did the melting clouds.
Yes. Yep. Oh, so yeah, maybe there's some interaction with what seems like melting and.
It was Dali.
Yeah. Oh, that's an interesting point. Yeah. Mm-hmm.
I combined the two women and put
Oh, yeah, yeah.
The little house things that, yeah.
That's what it seemed like in your mind. That yeah, because it kind of seems like.
Two of them and stuck them in the building turned into one of those things, so that was totally good.
It's interesting, right? So it's just trying to illustrate a little bit about how your mind is able to represent this sort of visual imagery, which is the chapter, once the image is gone. So you don't have access to the stimuli anymore, but you still have some representation of the thing. But even still, there might be some things that are false about it, just because your mind doesn't have a perfect way, unless you have a photographic memory. It would be difficult for you to access all of this information. So that image sticks there for a minute, but fades away quicker than a perception necessarily. Okay, so today we are talking about visual imagery, which I skipped before, but we're here now. We arrived at visual imagery finally. So visual imagery or mental imagery. So the concept of basically why you can remember how many windows are there in the house that you live in. When you're not seeing that information, you still have some conceptualization stored. You can, if I tell you to close your eyes and imagine that type of thing, you're probably sort of walking through mentally that layout of your house to count the windows. When you might not necessarily consciously remember that you have, I don't know, how many windows do I have? 3. I live in a small apartment in DC though, so that kind of thing. That you can close your eyes and recall an image when you're not seeing it with your eyes. So it's sort of our representation of visual information without our eyes, just totally within our minds. So you're experiencing it's the same sensory impression, but the absence of that visual input. And it's actually not exclusive to vision. It can also be sounds. Like, close your eyes for a second and remember the song that you heard last, or a song that pops in your head. Right? You're not hearing the actual music, but you have some access to that. You're still replaying that mental audio imagery in your mind. Mm-hmm.
Could this be applied to dreams too? Like when you dream yourself in like your hometown or in your house, and like you can see everything perfectly, although you're unconscious.
Absolutely. So as we'll see like a little bit throughout the chapter, the neurons that would be firing when you're seeing these actual physical things or hearing these actual physical phenomena, they're going to be active when you're imagining them as well. So it shows you a little bit about how you're recalling the same stuff that produces that image or that sound, even though it's not actually present. So it's kind of like a ghost or like a shadow of what was before. So why is this useful? It's actually kind of beautiful if you think about it. So it also, the understanding that you can create imagery or synthesize different things like that dream state, putting different imagery together, experiencing it as if it were in front of you, allows people to generate insight. So dreams might reveal to you the true nature of something that you're experiencing, but it's on the tip of your tongue, you don't quite know what it is. It also can support things like scientific discovery, or there are some famous artists who, you know, can imagine things or things pop in their head, these ideas, even though they're not experiencing them physically, they're experiencing them in their minds. So it can assist with problem solving in a similar way, and it adds a dimension to purely verbal thinking, and I want to show you just an example of that really quick. In terms of computer science, basically, like your computer, if you're pulling up images on the internet, it looks something like this. Or this would be if something was stored within your computer, this is how your computer understands that image. It's not the image itself. It's not even understanding it in terms of the letters that it's projecting to you. This is even an image, even though it's words. it's representing it in terms of zeros and ones, but it's not even the zeros and ones. It's actually the on and the off. So it's the presentation of an electrical signal, same with your brain, or the not presentation of that electrical signal, and how all of those things interact. It's not that a picture is actually in your mind, it's deconstructed and synthesized. And your final perception of it might be this mountain view, but the way it's represented is not that. It's not that physical picture. Whereas, in the physical world, if I have a painting, like it's a painting, it's not zeros and ones. It's a physical thing that has these chemical elements on it that reflect light and look blue to you in certain ways. Whereas it's not when it's purely in your mind or purely on a computer. It's digitized. I hope that helps sort of some of the explanation. Okay, so what we were going to try to cover today, and we've kind of goofed around for a little while, so we'll see what we can get through. But next week, so remember next Tuesday we don't have class, so next Thursday is set to be your review, but we're going to just cover as much as the visual imagery as we can, and then finish up and then have the review for your third exam. But anyway, so we're talking a little bit about the history of how imagery was studied and has become known to us. Imagery debate, so that's a little bit of a part of it. Behavioral research dealing with imagery. Psychological research dealing with that, even that behavioral data of how we understand imagery. And then imagery and memory, sort of those connections. So a little bit about the history of visual imagery. There has been a controversy on the topic of imagery. So basically, it's an element of consciousness. It's in that black box. It's difficult to actually be able to study this. So it shouldn't be surprising to you that the dawn of this behaviorism, they wanted to throw this out the window like everything interesting. So it was studied for a while, and then it was not studied just because behaviorists wanted to see actual inputs, outputs type thing. And they basically said that it wasn't concrete enough. There's no way to prove that you have a mental image represented in your mind, therefore let's forget about it, which is sad. And that's why we are studying it now in cognitive psych, because it's actually interesting and we like the black box, right? So there are cognitive methods to measure that imagery. We're talking about a little bit in these experiments. So pair-associated learning and mental chronometry. Okay, so this idea of imagery might be well demonstrated if I say to you, imagine a boat and imagine a hat. If you close your eyes, you can imagine images of these things. But if I tell you to close your eyes and imagine love or cruelty, there's no real physical proxy in the world for those things. You don't see love. It's a noun that's not experienced physically. Therefore, it's a little more difficult to come up with a mental image of it. So basically, this person in 1963 came up with just the concept of a conceptual peg. So imagery helps you to represent information. You have these things that are first thought of, and it helps you or it assists you with understanding that information or doing whatever task, your perception of it. Imagery is also, you can also study it in terms of time, basically. So remember, we might have talked a little bit about the mental rotation task. So presented with a picture, and you have to understand it in different terms. So this image on the left side of the screen, this is a task where you basically have to identify if the shape is the same as the other shape. And people will do this, as we theorize, with visual imagery. So you're not physically seeing the object rotate, but in your mind you're seeing the object rotate until it's in that position. And the amount of rotations is linked to time. So basically, the more dissimilar the positions of these two objects, the longer it will take for you to identify or to say that they are similar to each other. So obviously that's totally theoretical. We can't know if somebody's physically rotating the image in their mind, but it's a pretty good hypothesis, basically, that there's this connection between the time it would physically take for you to rotate an object if you had it in front of you. It would take more time for you to rotate it 1 dimension, 2 dimensions, and that would, in the physical world, make that difference. Therefore, it's somewhat realistic to think that in your mind, it's the same type of thing, that it's a parallel to the physical world, which would be that visual mental imagery concept. So it makes sense to study then imagery in terms of your perception of whatever object or that your perception of your mental representation of it. So kind of remember that perception is that strong sort of, you're seeing or hearing or experiencing that physical energy from the world that's transduced into energy that you are able to comprehend and represent in your mind. And remember that even perceiving something that you don't want to think about, as soon as you've perceived it, it still sticks around for a little while in like your short-term memory, or you can't escape it for a little while. You can try to push it out of your mind, but sometimes that doesn't even work. Like, how many of you have seen things and you say, oh, I can't unsee that. I wish I hadn't seen that, or I wish I hadn't whatever, right? You can't, it's strong. That perception is strong enough that you're trying to will it away, but you cannot even will it away. In contrast, mental imagery, it makes sense that there'd be some overlap between perception, sort of you experience that total visual imagery in your mind, and where it's larger scale than paying attention to that little thing that you create the perception of. It might make sense that there is some sort of parallel between perception and imagery. So here was a task that sort of tried to illustrate that or think about that. Basically, people would see this image of a boat, and then you would close your eyes and you would make connections between like different parts of the boat. Like if you close your eyes and say something like, so you fixate your eyes in one area, or you're told to fixate your eyes, you close your eyes, and then you're asked about something on the opposite side of the boat. For instance, you're supposed to look at the motor, you close your eyes, and I say, where is the anchor? And then you have to basically say that. So there's some connection between the actual physical difference or the physical distance between those objects and your reaction time with them. So it says something about the fact that your eyes would have to scan across the scene to see this, and your eyes scanning would take time. The same way that having this mental image, it would take time for your mind's eye, basically, to scan across the scene and see this. So there is a connection between the distance between two visual points in the physical world as with the mental image. So this guy illustrated throughout your chapter, Koslin, does a lot of research on visual imagery and has this interesting argument with another person kind of throughout that spawned a lot of research. But basically the conclusion from this and sort of the early work is that mental images are not as long-lasting and they're less vivid than your perception of the thing, so it'll fade quicker. You don't have access to everything that's within that mental image, but at the same time, you have that spatial correspondence that we're kind of talking about, so your visual imagery will be related in that physical distance type thing to your perception. So there's that connection between them. So that's a similarity. Also, so finding distinct parts of the object take longer in this experiment. Here's another one that's supposed to further illustrate that. So here's a demonstration. You should now close your eyes. Go ahead, do it. Close your eyes. So imagine your home state. Okay? imagine the city that you're from. Okay, now imagine a city that's pretty far away from that city. Okay, now imagine a city that's sort of in between that far city and your city. Okay, now I tell you to mentally travel from your city to the middle city. Okay, you have some reaction time to that now. Now go back to your home city and travel to the far city. Mentally travel there. Okay, and you have some reaction time for that. Okay, you can go ahead and open your eyes. So basically, there's that mental imagery in your mind of actually physically traveling from one place to another. And when people were tested about this, so there's an experiment here, people visualize this island. You're mentally traveling from one destination to another actually takes you a difference in reaction time. So it actually takes less time to travel to a close city, even though it's just a mental representation. It's just something you have in your mind. There should be no real difference between the close city and the far city, yet it still takes more time for you to mentally travel to those destinations. So again, it lends just a little bit of more credence to the idea that this visual imagery is a representation of that physical object. Whereas, say, a computer having this, it's called an array, so knowing kind of the data in the system, the computer not seeing this visual representation would take the same distance to get from one place to the next. You don't. For some reason, you actually have the physical representation in your mind, and it takes you longer. So another person, I can't pronounce this, 3 Ys, Pilation. Yeah, that sounds good. Pilation. So this individual, I think he's male, had this other idea of maybe what we're thinking about, or maybe how visual imagery is represented in the mind, that instead of keeping that map, that representation that it takes you longer to get from one place to another, it's simply stated in terms of language and symbols. So the idea of cat being under the table, there's that propositional idea of it that you'd write in a sentence, the cat is under the table. So the propositional statement would be under at that point. So in language terms, that would be the representation, whereas in visual terms, you'd see a picture of a cat being him or herself underneath the table. So it's an idea that might be true, and it's hard to test, right? Some cognitive stuff, so you have to come up with experiments. So Paishlin person kind of had this idea that maybe that distance or maybe that reaction time difference, even though it's present when you're studying this mental imagery, maybe it's an epiphenomena or even a, I forget what it's called in your book, but essentially it's your knowledge, your pre-existing knowledge that it would take you longer to physically travel is accompanied with that idea. So you unintentionally remember that it takes time to travel from one place to another, and that the longer distance you have to travel takes you longer. So you unintentionally bring that with you into that perception. So you'd still see information in these sort of decomposed representation, symbolic representation, but you would have this sort of effect of knowing things accompanied with that. So in this, so Paishlin person, Pilation, yeah. The criticism, or this was the way of thinking about that original Coughlin boat experiment. So it in terms of the time it takes for you to get from one place to another, that's accompanied by knowing that there are different representational kind of nodes. There's still a distance to travel conceptually of the links between how you can say the words between the things. So to get from the propeller, the motor, to the front deck, you have a physical distance to travel along the boat. So if you're actually scanning your eyes from one place to another, that's the physical distance. But you also have this representation that the motor's connected to the back of the back of the boat's connected to the cabin of the boat is connected to the front of the boat, etc. So you know that there, in language terms, is a distance to travel as well as the physical distance to travel. So perhaps it's not our physical distance that's creating that reaction time, it's perhaps the conceptual difference of just the nodes of the words. So it's called tacit knowledge. Basically, when you're scanning this object or when you're using whatever pre-existing knowledge of the thing that you're creating a visual representation of, you use that previous knowledge. You use the fact that you know that this is connected to this, and these are the different node connections within that image, or that it takes longer for you to travel some certain distance. So you unconsciously are bringing that knowledge into the way that you're perceiving or the way that you're interacting with your visual imagery. So basically said that, hey, this approach, this language thing, like this could work. This is how you could use that to explain Koslin's findings. And basically the fact that this person had this pre-existing theory and then somebody else comes in and says, no, I think you're wrong and I think that my theory is actually the way to do this, kind of sparked a debate or an interesting, like, no, your science is weak, my science is better kind of argument, which itself stimulated research. Remember that scientists have egos and they want to protect their own theories, and you even have people that follow them, people that study under them type of thing. So there's motivation there, basically. Somebody coming up with an alternate hypothesis might propel research just on the basis of, that human urge to be right. So here is an experiment that basically tried to attack pilation. I'm going to mess that up every time. So basically in this experiment, a series of X's are presented on a screen. And then, so that's flashed on there for a few seconds, removed for a amount of time, and then you have an arrow presented, and participants have to say if this arrow pointed to a fixation point, one of these X's on the screen, or not. And the result of this experiment was basically that the distance from the point of that arrow to the actual point, so it might be referencing a point, but it might be further up the screen. It might have the distance between the point of the arrow and the point that it points to. If that distance is greater, it takes participants longer to notice that or to recall that the arrow actually does point to whatever point. So basically lending more credence to the idea that it takes you in your mind the traveling of a physical distance or the representation of traveling a physical distance rather than just knowing that, yes, that arrow points to that X. Because it does. You could say in language terms, yes, that arrow does point to that X. But the difference, that it takes you longer to recognize that if you have to travel a mental distance, that lends credence to the idea that, yes, it's represented visually rather than just these prepositional terms. So even more credence to sort of that spatial rather than propositional. If you imagine a car at a distance, or if you perceive a car close to you and further away from you, your ability to notice details about the car is going to be easier if the car is closer to you. Makes sense. You're seeing something kind of bigger. Maybe your distracting details are less evident if it's right in front of your face. So it makes sense that in the real world you can notice or you have a clearer picture of something if it's closer to you rather than further away from you. So what's the then parallel in the visual or the mental visual field. So this was an experiment basically to illustrate that or to think about that. So participants basically closed their eyes and imagined two different setups. So a rabbit next to an elephant or a rabbit next to a fly. So the elephant in the first picture, the elephant is much larger. It represents more of your visual field, or it takes up in your mind more of your visual field than the rabbit. So if I ask you, does the rabbit have whiskers? Participants took longer to state if the rabbit had whiskers, if it was in comparison further away than closer to you, basically. So why should that make any difference? We're thinking of rabbits. We know that rabbits have whiskers, but that, I guess, lends more credence to if you are in your mind seeing a rabbit as further away from you, it has that sort of parallel as if you're seeing that car that's further away from you. So, yeah, more kind of along the lines of there is that relationship between imagery in your mind and real physical imagery in the world. So in the same way, the same type of phenomena, if you ask somebody to imagine moving close to this thing until the idea of overflow, visual overflow, which would be basically you're imagining walking towards something, or you would be walking towards something, like if you see those magnifying from space, like the Earth from space, and then you get closer and closer and closer to things. If you get closer to something, like basically the lines of it start to expand and overwhelm what you're able to see sort of in your periphery. So that's kind of the idea of overflow. So imagine walking really close to an elephant, eventually you're only going to see a gray space in front of you. That's overflow. So basically participants were asked to, in their mind, travel some distance and get close to whatever animal, whatever thing. And even though it's totally represented in their minds, they still perceived some distance difference between the elephant and the rabbit. So the image of a rabbit, in your mind, you can get to a foot, or people said they could get to a foot away before it would spill over the edges and you can only see white. Versus for an elephant, they said they could get 11 feet away from the elephant. Again, representing that an elephant is a bigger animal, so we see sort of that difference between the perceived heights of the animals, even though it's a total mental representation. So it's sort of that understanding of the scale, so the real physical distance and space of things within your mind. Now we're talking about sort of the idea of perception and imagery. So it makes sense that if, again, we're talking about perception and imagery, if we think that there's some relationship between them, then there should be some interaction then between them. If you're exposing people to these concepts, basically like they share the same pipe work in your mind. There are things that are accessible to each of those things, and if you're experiencing both perception and visual imagery at the same time, it should have some interacting effect. Like if you flush your toilet while you're in the shower, then possibly it'll flash hot water on you. You know that concept? Basically that your plumbing shares sort of the same lines, that if you affect one thing, it'll affect the other thing, that they're connected in that way. So is that what's going on with mental imagery and perception is sort of the question. So here's an interesting experiment. Participants were instructed to sit in a room with sort of a black empty screen in front of them and to imagine, in this case, a banana. So participants were supposed to visually or mentally represent this image of a banana, and they were unaware that behind the screen, very faintly, there was an image of a banana being shown to them. So they weren't consciously aware, but they were perceiving the banana. And the result is that people did see the banana in the same orientation, or details about the banana were the same as the image that they were unconsciously perceiving. So they had no idea, or the people said that they had no idea that there was actually an image of the banana there, but their mental imagery was affected by that perception of the banana. So it's showing you a little bit of that connection between the two things. Is that kind of clear? I just want to make sense. Okay. You have a clear mental representation of that? Yeah, cool. Which is kind of interesting. It's that sort of manipulation thing. So people didn't know that they were being manipulated by that thing, but they were. And how easily we are all manipulated. Kind of scary. And again, here's another experiment trying to flesh out that connection, or that interconnected nature of perception and imagery. If participants were asked to look at a blank screen and imagine a letter, either an H or a T, if then they were presented with a blank screen, and in a few seconds there'd be the target letter, either the H or the T. If they had imagined the same target letter, so they imagined an H, and the H is what was presented to them, their reaction time was quicker if they were presented with the H rather than the not corresponding letter, the unimagined target letter. So basically that, remember priming, like if I expose you to some stimuli, like those things, those neurons are recently activated, and it'll affect your performance. The same thing is happening if you're visually representing that information. So it's showing you that you can prime somebody just by making them think about that visual thing rather than even just showing them, which is kind of interesting. We'll get into a little bit about then, so we have those behavioral techniques that are fleshing out this concept. Now we're talking a little bit about how the brain is representing it, and if you can really see that in these brain imaging type studies. So there are these sort of, what is this? The temporal and the occipital lobe are responsible, are engaged with sort of these visual imagery as well as perception. So this is an experiment where they have brain imagery. Or I think this is actually, they had electrodes implanted in a person's brain, and they were, so they were recording the input of those single neurons. So if you show a person a face, there are specific neurons that will respond to that will respond to a face but will not respond to a baseball, for instance. And same way, there are neurons that are going to respond to a baseball but not to a face. So if you present somebody with the image of a face, it will respond to the face and not to the baseball. Same thing if you just tell them to imagine a face and not a baseball. So if you see a face or you imagine a face, those neurons are activated. But if you see a baseball and you imagine a baseball, same neurons that respond to a face do not respond to the baseball. So it shows you a little bit again, like things are specifically coded for whatever stimuli, and they're active both if you're seeing it or if you're mentally seeing it, mentally representing it. So here's just a study fleshing out a little bit of that connection between them. So same type of thing, if you're exposed to the stimuli and you're imagining the stimuli, you do get a similar reaction. But in this study, it sort of shows you that the reaction is not as strong. So in the middle bump, you can see that it's still activated when you're imagining, say, a rabbit. But it's not, the activation is not as high. There's not as many neurons firing, or the firing rate is a little bit lower. So it's still active, but it's less active. And again, we're talking a little bit about the overlap between perception and actually, or mentally representing. So here's a study where people were presented with this image versus imagining totally this image, and then they were asked questions. For instance, is the object higher than it is wide? So this image of a tree. And then they were doing a brain scan, so they were recording sort of this activation when you're seeing versus imagining. And so you have the activation recorded in these cases, and then you compare the brain scans between them. So in the frontal area, you can see this image on the left. So the first one is perception. So you're actually seeing the image. The second one is imagery. So we have those two activations, so represented in that visual of the brain, but it's all data. So if you take then the activation you see for the actual perception, and then you subtract the activation that you would see for the imagining, you end up with nothing. So it shows you sort of that one equals the other to some extent, that if you subtract one from the other, you get nothing, if that sort of makes sense. So you're comparing sort of that activation. There's so much overlap that you're not seeing anything. Same with parietal areas of the brain. But when you get to the occipital areas of the brain, it's a little stronger for that perception. So if you're subtracting totally the response to imagining that image, you're still ending up with some remaining activation. And basically this makes sense because the occipital lobe deals with your vision more strongly, so it deals with your actual perception of visual imagery. It's sort of that basic part connected right to your eyes. So it does make some sense that even though these things are overlapping, there is some difference in your brain, even slightly, that things are not totally the same or not as strong necessarily with what you're visually actually perceiving versus what you're thinking about.
Like the more that you are exposed to a visual representation of something, and then you imagine it, like every time with the neuron, like the firing of the neurons for imagining, would it increase with time, like after you've been exposed to the image more?
I would say that's likely the case. So remember that when you're exposed to stimuli more, you get those changes at the actual synapse that it wants to respond more to something it's seen. So if there's so much overlap between that imagining and that actually perceiving, there's going to be definitely more activation in general to it. But I don't know the total answer to that, and I think that would be a really interesting research idea. If you are exposed to something more, is there more of a difference or less of a difference? So that's cool. I'll write that down.
What was the answer to that, whether it was wider or higher?
Looks like it's wider, right? Yeah. Yeah, and right now you're experiencing all of that stuff. You're experiencing, before when you were asking me if it's taller or wider, you did the experimental condition where you're just imagining, and now we're looking at it again. Science. Okay. I was just writing a note. Don't remember to, yeah. That's the only way I do anything anymore is if I write it on my physical body. I'm sure you're there too. Anyway, so again, there's a lot of similarity, but there are differences. And how do you really study that? If you have, or if you know that there's a lot of similarity and that, it's difficult, you can show somebody something visually, and you have a lot of control over that. You physically make the image and you physically show somebody the image. But there's a difference, or it's a lot more difficult to really affect what a person is imagining because it's their brain. You don't have a lot of control over their brain. So that's why lesion studies have been really useful. And now, current technology, we have this really great, really scary thing. Transcranial magnetic stimulation. Basically, you wave a wand over somebody's brain to make parts of it stop working. So you create an artificial lesion. So you turn off parts of somebody's brain with this magnetic stimulation. Isn't it kind of creepy? It's kind of cool too, right? So exposing them to that for a little while can cause seconds to minutes of that brain area not working anymore. So some brave souls will volunteer to be in research where you create an artificial lesion using this and parts of their brain shut off. And then in that way, it's basically like studying the brain with the lack of, so it's like you're taking out that part of that person's brain. And you basically say, if this is related, then removing this will affect this phenomena, right? And then you can study that pretty easily. Basically there was this experiment where, got a question? Oh no, just stretching, okay, sorry. So this is sort of getting back to that same debate, the epiphenomena or the tacit kind of knowledge thing. If something was only represented in your brain, or something it did not need that visual field. It did not need to be affected by the actual distance traveled between the two things. If that was just our external knowledge of whatever thing, then turning off that visual part of your brain should not affect the actual perception or the actual reaction time between the things. So if it was totally not necessary for your visual imagery or your visual understanding, then getting rid of the visual part, shouldn't matter. So if it's all language, visual shouldn't matter anymore. So basically this experiment was still a little bit like in your face, my way is the right way. And they turned off the visual parts of the brain and did see that there was an effect on the ability to mentally recall. So again, lending more credence to the idea that mental imagery is really physically true. It's not just something that accompanies the way your brain processes information. So we're not totally like computers in that we have all the bits totally decomposed in our minds. We have something more lasting of that mental representation between the things. And that's what we got for today. So we're pretty close, 30 to 41. Great. So have a good weekend, have a good Tuesday, work on your papers, ask me questions, and I'll see you next Thursday.